Hi folks, let's try today the problem 953 on Leetcode, verifying an alien dictionary. And here let's read the problem. This has been, by the way, characterized as easy. So it definitely doesn't look easy, but let's take a shot anyway. Verifying an alien dictionary. In an alien language, surprisingly, they also use English lowercase letters, but possibly in a different order. The order of the alphabet is some permutation of lowercase letters. So, what these two statements tell us is that there is a alien language where they use the English alphabet even though the order of letters in their alphabet may not be the same as the order of letters in our alphabet here. So having said that, let's read the second paragraph. What it is trying to say is that given a sequence of words written in the alien language and the order of the alphabet, return true if and only if the given words are sorted lexicographically in this alien language. What does it mean? Basically, they will give us a bunch of words, a sequence of words, and the order of the alphabet is basically also be given to us. That would be our input, and we have to return an output of true if and only if the given words are sorted lexicographically. Lexicographically means that when you look at a dictionary, you see that the words are lexicographically sorted. So if you ever had a chance to look at a real dictionary in a written form, because these days everybody is just trying to look up things on their phone, and you have all the apps for every kind of thing you want to look up. But there were days when people actually used dictionaries, real in book form, and you had to actually look up words in that dictionary. So basically, when that happens, you would see that the words are lexicographically sorted in the dictionary. So you would see, for example, if you just open some page, you would see, for example, if you randomly open a dictionary and it goes and lands at some bunch of pages which have words starting with the letter L, then you would see on the left side of it, you would see the letters, for example, the letters of the alphabet that or the words that start or precede in the alphabet before the letter L. So A, B, C, D, E, F, G, H, I, J, K, all those words you should see actually. All the words that start with these letters would actually would have occurred before. So that's what lexicographically sorting means. So now let us coming back to example. So example is input is words. So hello Leetcode. So he gives you two words in the alien dictionary, and then the order is HL. So HL. So he's saying H comes before L in the alien dictionary. That tells us immediately that the first word is basically coming before the second word, so everything is looking good and we should return true. Now let's take the example 2, and he gives us a sequence of words known as word, world, row, and then the order is WORLD. WOR. Now, if you look at the words that they gave us in this case, which is WORD, WORLD. So as you can see, there's no problem until WOR, but the problem will start when you have D, and you have to compare D with L. So for that, let's look at the dictionary, which comes first. So as you can see in the dictionary, here I am highlighting here, you can see actually L comes before D. If L comes before D, then obviously this order here is wrong, because you see this is D and this is L, so it should have been other way around. So basically that means we have to return false. Now let's take apple and app. Now here we see that apple and app, and they have the app shares all the letters with apple, but apple has more letters than app. And so here the problem is that as you know, in a real dictionary you would see that the words that are longer in length would have to come after the words that are shorter in length. So basically it should have been other way around. It should have been app and apple, not apple and app, and that's why we have to return false here. So here, that's why it's saying here, according to lexicographical rules, apple is actually greater than app. So it should have come other way around. Like app should have come first app, but here the order is wrong. So that's why we have to return false. So he has also given us some constraints, and constraints are that the length of each of the word is less than 100, greater than 1, and then oh, actually this is not the length of each word, but this is the low length of the dictionary. So the input dictionary, the sequence of words that he gives us, you will not have more than 100 words basically, pretty much, and at least you will have one word. And here each word would not be of more than 20 characters. That's what he means to say. And the order of length is 26. So the aliens have 26 letter alphabet, even though it may not be the same as our alphabet, but the letters are the same. So, and here he's saying all characters in words I in order are English lowercase letters. So these things kind of make our job a little bit easier. We don't have to worry about caps, capital letters, and things like that. So let's start now. How can we do this problem? What should be our approach here? So the approach is, if you take, let's try the approach or our algorithm first. That will give us some framework to basically solve this problem under. So what we can do is we can compare each word with the preceding or its succeeding word, and we can try to check the order anytime. So basically let's do this. So you say compare or check, compare slash check order of words, or you can just say a little bit more in a programmatically, word I with word J, and we will basically define this. Also tells us that we would need two indices I and J, because if you're comparing different items in the same sequence, you have to have two indexes to basically be to basically corresponding for those words. So basically compare slash check order of words I with word J and return, okay, and where I less than J, and he say return true if word I is less than word J lexicographically. Now here we will use the word lexicographically, and I think this lexicographically seems to me either the Roman or Greek origin of this particular word lexicon. It has come from lexicon. So lexicographically, okay, so that is pretty much the approach we would take, and we can use the order first. Create a dictionary This is our own hash map or dictionary, whatever you want to call it. Create a hash map of the letters the in the dictionary. Create a hash map of the letters in order. Let's just say order here, because the order is our input. Letters in alien language. So basically, what would this hash map have? This would have the letter and its index. So if, for example, in this case, if we take HL, so H would be 1, and similarly there would be L would be having its key as 2. So we would be able to immediately take a letter and go and index into this, basically look up into the hash map and see where it occurs in their alien language. So let's so so that is going to be our overall algorithm. And okay, so first thing is to create a hash map. So let's call that as D, and we would say D, we will initialize D as like a typical Python unordered dictionary. By the way, this is an unordered dictionary, this is not the ordered dictionary, which is of no, which actually is not important in that case. We don't need an ordered dictionary. All we need to know is what is the mapping between the word and its occurrence in the alien alphabet. So we will say for C in order, DC equal to the index of C in order. So how do we get that? So that can be gotten from multiple ways. One way is we can, oh, I see. We can, what we can do is for I comma C in enumerate order. This is a very neat little Python trick. You don't have to convert this order into a list or somehow keep a counter while we are walking this order, these characters in the order. We can simply say for I comma C in Python will do our job here. So we say enumerate. I think enumerate spelling sounds to me wrong. Enumerate. All right, there we go. In order. So this will give us, like, for example, 0, in this case 0h l1 and things like that. So basically 0h 1l and things. So this is a very nice function which returns an object, enumerate object, that we can basically iterate on. So dc equal to I. For I comma C in enumerate order, dc equal to I gives us the dictionary. Now what we do is we say we can write another function, which is, imagine we had another function here, which is def check order. We were leaving it, this is not yet complete, but basically we are leaving it, we'll come back to it soon. Right now we say def check order, and then check order would basically take the for, okay, so I guess here what should be the API for check order? The check order should have two words. So, and then it would return if they are in the lexicographical order or not. So we will say W1, W2, and possibly we may have to work on the, I think we may have to pause D as well, which is the dictionary. So all right, let's try to do this. So I think now that we know what check order will take, we can try to basically fill fill our the easy alien sorted function. So we would say, after having this say, we would say for I in len. So now we are basically walking the sequence given to us words. So say for I in len words, and so we are going okay, and then we would say for j in I. Now what should we do here? So we know that for I in len words will walk all the words going from 0, and here we want to have the j go up to, for each word we would, the j would start. So for example, if I is 0, then j will start from so for j in, okay, here we need, I think, range. I don't think this work this way. It is not a while loop. So for I in range len words, for j in range I plus 1 and len words minus 1. Why we are doing minus 1 here? Because as we know in Python, this thing will go, the I will run from 0 to len minus 1, and this will run from I plus 1 to len minus 2, so that we would be able to compare. We do not want to basically run over the length of the array. So that is the idea here. So I goes from 0 to len minus 1, and j goes from I plus 1 to len minus 2. Because, or we could have done the other way, which is that we would have run the outer loop actually for len minus 0 to len minus 2, and then the inner loop would have run 0 to len minus 1. I think that probably sounds better, because then we can do compare len minus 1 with 0 to len minus 1 is the complete sequence, and in the last, our last compare would be from len minus 2 and len minus 1. This is the last word, by the way, and len minus 2 would be the, and they seem to be a bit confusing because our indexing starts from 0. So we will say, we'll do the check order here. So if check order word I and word j, if it returns true, so see, as long as it keeps returning true, we don't have a problem. The problem is only if it ever returns false. If check order is false, we could also probably written this if not check order. Anyway, it's false. This is more Pythonic. Return false. And if that is not the case, here we would return true, and we are in business. So let us okay, here we are. So that is for I in range this, for j in range, it looks all looking good. And then all we need to do is implement the check order function for 2 individual words. So now we can write a little bit of comment here too, in case that's useful. Given w1 and w2, return false if they are not in lexicographical order. So this is also looking good. Let's start coding this one now. So what we should do is, in this case is, so for each character in W1, so say C in for C in W1, for each character in W1, should we do that, or we should say for C in W1 and for, so how should we do this? How are we going to compare the words here? Is there any methodology we can use? And so if you're walking the each character in, okay, so first thing I guess we have to do is that if these words are of different length, what should be our approach? So I guess we can only compare for the length which is common to both. So if this is 5 letters and this is 3 letters, we have to take the minimum of the lengths of W1 and W2. So okay, so that is trying to make things clearer. So for I in range min, and then we say len W1, and min will need 2 arguments, so len W2. Okay, so now we are slightly making more sense. So for I in range min len W1 len W2, for this we want to only compare the number of letters that are common to, or basically for the not so because we are comparing two words and they can be of different length, so we should only compare up to the length of the smaller one. Basically that's the idea. So now say if D, which is already with us, D and then W1 I guess W1I would give us the letter that corresponds to. Now the thing is, these letters are still these words W1 and W2 are still the strings, and is are we can we index into strings the way we are doing it here, or do we have to convert them into list? Let us see. If we find a problem, we will go ahead and fix that one. We may have to convert these into lists. So we may have to say like W1 list equal to list W1, and similarly W2 list equal to list W2. And then we may have to say, I mean, I guess that one would still work, but here we may have to say W1 list I. But for now, let us keep the code as it is. We may have to either take it out later, or if it doesn't work, we may have to use that. So if dw1i is greater than dw2i, then we have a problem. Why? Because how could that means w1 should have occurred actually after W2, but it's actually other way around. So we have to return false. Or what we can do is we can actually also have a flag maybe. Should we return false here, or we should just return the some flag, I guess. We'll see the flag later, but I guess, can we return false here? Else, if this is again Python, so we have to keep track that also in mind. If they are less, then we don't have a problem. So else if dw1I less than, then we return true. Then we basically return true. So if we don't hit any of these conditions, then what happens? So imagine that they have the same letters for the minimum length of the two. So neither they're greater nor they're small. So we hit neither of these cases. Now what happens? So for that case, because remember we have another example 3 here, he says, the test case 3 he says is, when you have two letters with this same number of exactly same letters in up to the length of the minimum of the two, then what we need to do. So that could also be the case here, because you know you're doing this comparison and you're doing greater or less, but what if they're exactly equal? And if that happens, we would, let's use a flag, and we say flag equal to true, and actually flag equal to false. And if we do not hit any of these cases, then what we should do here? If we do not hit any of the cases up to the, so if flag is never reset, so let us see, if flag is remains false at the end of it, then we know that they have exact same letters. So flag is still false. So maybe, you know, what we can try to do here is, if flag is false, if not flag, in this case we might as well have set to true, so it becomes easier. So if not flag, that means they have exact same number, and then we say if, or maybe we can put it, if flag and len w1 is greater than len w2, we have again a problem, because if flag is true, and that means we now they have exact same number of letters in the for the length of the minimum of the two, and length of w1 is actually greater than len w2, then we can also return false. So that would take care of this case, apple in app. And if none of these things happen, then we return true here. How is that one? So let's try to see if we have any success in, so let's see. Okay, what is saying, invalid syntax for n comma c in enumerate order. Okay, that's easy to fix before I put a colon there. So let's just run again. Okay, so now it's saying that check order is not defined. Now what's that problem? That problem is coming because what happens is, he's trying to see that for this object solution, is there a inside that object, inside that class, is there a check order function? And usually, you know what happens, if anything is an object instance, like member variables or member functions in Python, you will always see them preceded by self, because ultimately that means it's a member variable or member function in this case. So without that, he's looking for some, maybe a global variable, or maybe something that is a class instance or something. But in any case, so let's fix that by saying self dot check order. Okay, so now we have a problem, and then the problem is he's saying, okay, so that we can fix ports and words here. That was easy. Okay, so now check of missing. If check order, okay, missing, sorry, if self dot check order is false. What is it missing? Type is positional parameter D. I see. So we forgot to pass the argument D. All right, that is looking great. Actually, I wasn't even expecting it to pass in the first time, but apparently that one has worked. Now, can we see if the submission passes as well, given that they have more test cases? So let's do a submit. Awesome, awesome. That's great, guys. So, guys and girls, by the way, because I do not want to be a sexist, and I feel women can be as good programmers as men. So, so given that that is the case, let us celebrate our success by calling it a day today, and then maybe we will have more solutions. We'll work on more Leetcode problems going forward. He talks about next challenges, which is largest values alphabet board path. I mean, I have never heard any of these. So high five, that sounds interesting, Nam. Maybe we'll do that next time. But until then, I wish you all happy coding. Adios. Take care. Bye bye.